My name is Matthew Khouzam, and I have the privilege of making the world a better place by being able to contribute to open source through Ericsson. I am very grateful for that, but today is different because I'm in front of a giant group of people and you all get to do the same thing. You have different companies that are helping you do this, but we're all making the world a great place. And I think that we should take a little moment to appreciate the opportunity we have on that. Now, this talk in particular is CDT Cloud, the embedded SIG, Cloud Dev Tools, OpenVSX, and how does this all work together? It's more of a story of how the Eclipse Foundation works, and it allows us to work together. There is not very much technical in this talk, and I will forgive anyone that wants to step out in the middle. But what I'm going to do at the very end, I'm going to just try to bring it in with a little bit of a demo of CDT Cloud and one of the latest developments in there, a contribution by Eclipse Source, which made the Trace Compass backend work well on it. So let's get started. As I just said, I want to get rid of some ambiguity. Now, one thing is that we have a lot of, I've noticed we have a lot of silos in internal, in every internal group that I've seen, not at Ericsson, just in general. And it's the human nature. You want to perfect something. And when you want to perfect something, you have to prioritize it, and you have to deprioritize things around you. But just knowing what's going on around you is enough to start building these bridges. So, you know, one thing that we'll try to do is avoid the acronyms. So, about me, the interesting thing is that if you look at me from a datasheet point of view, my core values are probably creativity, exploration, and collaboration. I work at Ericsson, and their core values, and I know this because it's on their website and verifiable, and honestly, everyone that I've worked with within Ericsson exemplifies these, is professionalism, respect, perseverance, and integrity. I'm also privileged to be on the board of directors of the Eclipse Foundation, and their values are service, respect, professionalism, and collegiality. I think that for me and for Ericsson, we are at the right place. This is people talking the same language and wanting the same thing with just slightly tweaked words. So let's start with the original CDT. And we have the privilege of having the lead of CDT right here. So it is the C Development Toolkit. It's absolutely loved and embedded. I know because this is probably the first tool that I got when I bought my own microprocessor boards. It's used by C++ developers. It's Eclipse ID classic based. And why am I talking about it? Just remember the acronym. CDT is not Eclipse Theia based. So what is Eclipse Theia? Eclipse Theia is not an IDE. Eclipse Theia is a platform to build modern IDEs. Now, if you take CDT and you add CDT to it and you add Theia, you get CDT Cloud. Now, this is a framework to build modern IDEs, C++ IDEs. I'm going to get more into it later because there's a CDT that I didn't explain yet. The Eclipse Cloud Development Tools Workgroup. So yes, we have another CDT. So it's the workgroup where well, I recognize most of these faces, which is a wonderful thing. A lot of these people will come together and be able to have their projects which all aim to solve the same problem, but from different angles, and they can collaborate together, which is great. This is putting all of our resources in one bucket so that we all solve the same problem together. On a side note, congratulations to Adoption that it's the newest member of the CDT family. But that's another story. Next up, the embedded SIG. So what is a special interest group? Well, it's a group where people have an interest that's special, obviously. But with Eclipse, they have a proper terminology where they say that this is a place where you discuss specifications and documentation and no code. So we were discussing embedded needs, and embedded needs code. So in comes the CDT Cloud project. Now, this started in parallel to the embedded SIG. In here, we have the people that were developing a C++ IDE that's cloud-based, and it's based on Theia and the CDT, actually CDT Classic also, because it does use some of the debugger aspects. And it's not a work group, so it's not a place where people, where managers come together and say, we need X, we need Y. And it's not a SIG. It's not a place where we write up documentation. It's where the code actually happens. And remember, the slogan for Eclipse is, it's in our code. So this is kind of the end break, but the end game. Let's take a look though. Let's just do a little repetition. A working group, once again, is a community where Eclipse members pay dues and have an Eclipse manager come in and help them manage their project. Now, Eclipse projects are hosted within working groups. One example that you've heard in the keynote today is SDV. Another one you've heard in the talk today is CDT. An Eclipse special interest group is a community hosted within a work group. You don't have to pay dues for it because you already paid for being in the working group. And it has no code output. It's just documentation. But you need these specs. You need all this stuff. So an example is the Edge native SIG. And finally, an Eclipse project is where the code lies. One example that I'm giving here for it, I'm pretty sure we're all at least writing Eclipse or using Eclipse if we're at EclipseCon, so we know what a project is. Let's go with Titan. So here's a fun quiz. Is CDT a project or working group? Both. That's a problem. So one of the minor tweaks is that now we put a tiny E in front of the working group, so it's ECD. But then there's the insistence on Eclipse branding that we say Eclipse CDT. So we come back to the same problem. So one example for CDT is, I have a feeling that was, oh, yes, so many of the projects within CDT Cloud are VS Code extensions. This is just an implementation detail I wanted to get into. And so this actually is very powerful because it makes everything modular following an API, which means that releases no longer need to be lockstepped. Which means that if a project I'm working on hits a technical hurdle, everyone else can keep working on their things and not wait for me. So yeah, decoupling is always good. And Theia, I wanted to give a little friendly reminder, has cool features for VS Code plugins, such as detachable windows, so that you can actually detach your plugins and put them in other screens. Multi-monitor support's very important, and these are all hosted in OpenVSX. So now, they both lead to CDT Cloud. Let's see the Ericsson perspective on this one. We need C++ development. This is no trade secret. Just look at job postings for any company. If you see that they're hiring people to develop C++, there's a good chance they need people to develop C++. We don't pay for nothing. And we are actively contributing to several projects in this domain. Memory Inspector, Trace Compass, Eclipse Theia. So now, I did mention that all these things are hosted in OpenVSX. What is OpenVSX? VSX is huge. It's so huge, I have another talk on it, I believe tomorrow. And so the OpenVSX registry is a service offered by Eclipse, where you can download these plugins. Now, but the Eclipse OpenVSX project is where the VSX code server resides. So there is that distinction. It needs more budget than the Cloud Dev Tools Working Group had. And there are several reasons for that. But when you look at the amount of bandwidth that it took, and you look at the amount of stability issues that it had, because it's a victim of its success. It got so popular that everyone started overwhelming the server. You know that it needed a full-time manager and like a few devs on it just to know what the problem was. But I want to give you another reminder. Without plugins, VSX is useless. Without VSX, or without a place to get plugins, the new modern IDEs are useless. All of this plays together, and we need everything together. So now, let's talk about Ericsson's FOSS strategy, and I want to give you some context. Ericsson's a big company. I got this data off their website, but I rounded a bit. I don't remember if I rounded up or down, honestly. I think I rounded down on one, up on the other. We have 100,000 employees. We have 30,000 research and development employees, but we also have developers, and we have sysadmins and all that extra. So we have more than 30,000 people that need to do software. But we're not a tools vendor. But imagine that we were, and we had a village of over 30,000 people that need our stuff. So Ericsson invests very heavily into Eclipse, and we see it being worthwhile. One of the main reasons, too, was the talk right before, where we were talking license compliance. Eclipse is very good at due diligence. And so this is a kind of contentious point, but Ericsson is a telecom company, and it's not an embedded company, but we had interest in the embedded SIG because we work like an embedded company in many ways. And I think that's because of a misnomer. I would like to call an embedded developer a real full-stack developer, because then you start getting into the hardware, the protocols, and all that. Like, just saying server and front end, when did that become a full stack? So, you know, I want you to think, all of you here, do you have a problem like this? Do you have a similar situation like this? Like, if so, Cloud Dev's Tools is actually a very useful platform, and CDT Cloud is a very useful place to discuss these kind of issues. I would argue that we migrated beyond the scope of embedded. Now, as I was saying, we support our internal developments. Any improvements on the tool chain represent savings. Now, let's say we have 30,000 developers, and I saw a really cool quote by a handsome gentleman earlier where 2%, if you get a 2% saving, that's 1 week a year. Now, 1 week a year times 30,000 developers becomes very big, very fast. Now, we're not going to get the 30,000 people working on it, but if we get even 1,000, you know, I've already paid my salary and my vacation that's extra. And one thing that's super important to understand with open source is that it always gets better. Or tomorrow, bugs get fixed. We don't get a new policy that says, oh, we're locking down this feature because now it's popular so we can start monetizing it. You know, it just gets better for the user every day, but there is a cost. We got to make it better. So yeah, we develop in C, C++, Java, Python, TypeScript, and more. You can see this in our job postings again. I am bringing the question again out there. Are any of you in companies, or do you know people in companies that have similar problem spaces? So I wanted to make a quick demo of CDT Cloud. And I'm going to be focusing on Trace Compass, which is a trace visualization tool that is hosted within it, but it's not because all the other tools are less interesting. It's just that this is the first time that I see it available on the CDT Cloud website. So let's see if I can get it to work. I'm going to and while this is happening, I'm going to discuss a bit of traceability. I'm going to put down the mic because I need both hands. I hope you all saw this site. try Theia Cloud IO. So now, what you do is you find your cursor, which is there, and you go to Theia Blueprint. But we're talking CDT Cloud, so we go to CDT Cloud. And then we go log in, and you click on the correct button while looking at that side. And now, since I logged in, back here, whoever wrote these, I really appreciate the terms and conditions. They are very clear, and you do not sell your soul to anyone. I gladly accept, and I load. Now, what I'm doing now, I'm just doing a quick load on this one, and the reason, and while this is happening, I would like to go back to, no, that was too fast. It was a little slower before, but basically there is a question of scalability with cloud-based tools. And this is a huge opportunity for a lot of us that make tools. There's a collaboration that I wanted to announce, which is that Ericsson is collaborating with École Polytechnique de Montréal, which is pretty well known, and with AMD, where we wanted to make Trace Compass scale. Now, let's say that you have one server, and I'm pretty good at selling things. Let's say you have a cloud with 10 machines. One server can handle that, no problem. What about 100 machines? What about 1,000 machines? What about 10,000 machines, but just to make things more interesting, with 1,000 cores each, and with 100,000 threads each? There's no way we can scale to that level on one machine. But what we have done now is we've started leveraging the cloud-based infrastructure, and we have a project, I'm going to be showing it in the next slide, which will allow you to have a tiered architecture for the server and make it distributed so that it can be handled. This is a little tricky in some areas, and we have a very brilliant student that's working on it. More on that very soon. However, for now, I just want to show we have our traces here, and this is 100% cloud-based. And to me, this is so cool that we're able to show it open with the trace viewer. Now, if you take a look, I am at the parent directory, so you have cat kernel and cat ust. These are two traces, and they are being multiplexed. Basically, they're being merged into one stream of data, and the results, oh yeah, merging traces, are greater than the sum of the parts. So now, what you can do is run your analysis, and here's a little feature that became very easy when we went for a distributed application. More on that in my VS Code transition talk on Thursday. Let's say you want to look at a different metric as an overview, as an index. You totally can. So now let's go here to, and I'm sorry for looking away from the crowd, to just a view at random, which has a really cool timeline chart contributed by Typefox and improved by Ericsson. Now here you can see what's going on your CPU, including your frequency scaling and your processes and when it's idle and not, versus your CPU usage. And then I'm going to just right-click zoom, and you get the information there. This is desktop speed. I have no idea where this data is hosted. I'm sure people in the back row know, but I have none, and I'm proud of not knowing. So I often get the question, when is Trace Compass going to be cloud ready? I'm going to say never 100%, but that asymptote is really close. So coming back, I'm going to do my best to restore to the wrong slide. This was the update on Trace Compass. We have the front end and back end split. The front end uses WebGL, WebGL has an advantage over SWT, where SWT, even though it's OpenGL, or it's hardware accelerated, every draw is one draw, it's not batched. So you can actually get nice performance with that. The back end is the same as Trace Compass, which has been optimized over years. But it is pretty fast. So yeah, I put the link of our students' trace coordinator. That's the way that we're going to have the distributed traces being aggregated. And I'm hoping that that's going to be a new CDT Cloud project soon, trademark. And yeah, wanted to make sure that that was available. But to recap, I want to make sure that you all know the whole architecture of how Eclipse works and how we can do such cool things within that architecture. That's the core of this talk. Today, we have the working groups that take care of stuff like making sure that we're all on the same page. And not only that, but we have an Eclipse-based manager that makes sure that we are on the same page within the foundation, so that if we have potential collaborations, that person would come in and help out. Not only that, but they do help on the mediatization. And from my understanding, they improved the process for all of Eclipse because of our requests, so that's cool. We have the SIG, and the SIG has three potential, a SIG, in my opinion, has three potential outcomes. It dies, and that's bad. It exists forever and generates a ton of documentation. That might please some people. And the other one is that it grows into something big and wonderful, like merging into CDT Cloud. And that is what happened, and I am thrilled to be part of that ride. So these projects take advantage of the previous expertise within Eclipse, but they're trying to do things a little differently and solve different problems, and that also is really cool. Like, we are leveraging the DSF GDB adapter, which, by the way, I'm very proud to say Ericsson has some code committed in there. And so now, in conclusion, I'm really hoping that if I say CDT Cloud is hosted by the CDT workgroup and uses parts of CDT, that makes sense. But really, we need better acronyms. Thank you. I would like to know, are there any questions, comments? Because I'm not above telling you that you can go get coffee at this point. Pardon me? Oh. You're right. Well, that's not really hard to do, is it? What you do is, I'm going to just have to find my cursor. That's the hardest part. I'm going to use the mouse, just because you can't see my keyboard. So you can go to Preferences, and then Color Theme. And let's do light. Oh my, it just works. Thomas. Yes, that is. Yes. So the question was, the client-server split, is that on the tracing side, the ID side, both or none? The answer is that the example I was giving is 100% on the trace side. Now, we take advantage of the ID side within Theia for being able to launch the trace server and stuff like that. We had to make a separate VS Code plugin, more on that on Thursday, for that kind of operation within VS Code. And so yes, and a funny thing, we got a patch contributed that allowed our messages to be passed from the front end to the Theia back end to communicate to the trace server. And that extra hop, of course, you know what the performance impact was, right? It accelerated by 10% the communication by using message pack. That's the consequence of using well-architected solutions. Other questions? I think we have a bit of time left. I was that clear. Perfect.